All right, so let's get into it. First up, let's do the warm-up problems, of course. I'm moving some stuff here so we can see it. So just reviewing, nothing new, nothing crazy, before we start adding new stuff to you today. So of course, just like I was gonna say yesterday, it was the day before I saw you. Inscribed angle, vertex is on the edge. So just to review, the angle is half its intercepted arc, which is 68. Now, I know a lot of you can kind of skip that half 68 and just put 34, which is totally fine, but you know the love of math, I gotta write it all out. From here, super easy to solve. We're gonna add one over to each side, and then I'm gonna divide each side by 5. Do it in your head. Got it. So this is a review of the previous section. And we're gonna see some more of that today, believe it or not. Now, these on number 2 are different. You have central angles. The vertex is on the center. Inscribed angle, central angle. Different. Okay. So lots of different things I see here, of course. They've got an arc here. We've got an angle. Remember, the angle equals the arc. So I see where X is, it's an arc. So I'm trying to label all my arc pieces, of course. The other thing they tell you is that AD and BE are diameters. I'm going to look at BE. So, of course, you've got the semicircles, the half a circle. So I've got 75 and 55. So if we add those up, 75 plus 55 is 130. So, of course, to get your remaining piece to add to 180, I know this would be 50. And guess what? I know this is 50 because they're vertical angles. Vertical angles are congruent. So I've got the whole circle labeled, I'm ready to go. So you have 2 choices now. I could add everything to 360. That's kind of obnoxious though. Or a little easier, we have the 2 semicircles. So let's cut it in half and just work on a half. I'm going to work on this left half. I'm going to add these together, the 50 and the x plus 135. And that's going to total me to 180, half a circle. So 50 plus 135, 185. I can't read and talk, plus 185. My hand still hurts. There we go. And then we're just going to subtract 185 off, and we get negative 5. So that problem was a review from the second section, just to give you a reference. The first thing we're going to talk about, because it says there are 3 new properties. One of them, believe it or not, you really already know. Okay, it's just going to look a little different. So this you already know. This is the first warm-up problem we did. You know the measure of an inscribed angle, vertex on the edge, is half the arc. So if this is 140, no work, we all know this would be 70. Okay? So that is true in these next coming up problems. That is true when we have it being tangent. Now tangent, remember, touches the circle. A little vocab review there for you. So here's our first theorem we're going to look at. You got to fill in a few blanks here. If a tangent, that's the first blank you got to fill in on the theorem, and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2. So let me give you a sec to fill those in, and we'll talk about it. Ready? Okay. So this, honestly, is nothing new. So I'm going to look at angle 1 first. So it's tangent. Its vertex is still on the edge of the circle. So it's still like an inscribed angle. So angle 1 is half this red arc. So if I know this red arc's 100, you automatically know your angle's 50. Nothing new. You know it. It's nothing new. Okay? It just looks different, maybe. Same thing for angle 2. Its vertex is on the edge. So if you know the arc, let's say this would be 260, my angle is half of that. So the first thing we're going to do is nothing new. The angles just look a little different, but technically they're still inscribed because the vertex is on the edge of the circle. So here we go. So line M is tangent to the circle. Now here's where, again, I wish we had color copy machines. You might want a different colored pencil or a highlighter, or, I don't know, bold it in at the very least, because they're asking you to find the measure of the red angle arc. Clearly it's not red on your paper, people. I wish we had color copiers. Okay, so bold in or a different color just indicate so you know this is what they're asking you to find. Now, I'm not going to be like, oh my gosh, what do I do? Which theorem is it? Same thing. Vertex is on the edge of the circle, so the angle's half the arc. So what's half of 130? So you got it. And again, I don't expect you to do any work for this type of problem on your assignments. Just write down 65 and be done with it, okay? All right, so indicate, of course, the red arc is what you're finding. So on your notes, highlight it, bold it in. I don't know, do whatever you have to do. Your vertex is on the edge. So to get the arc, which is clearly bigger than the angle, are you halving or doubling? Doubling. So 125 times 2, 250. So nothing new. This is kind of like a good review of what we did the last section. That's why I like it. Okay, find the indicated measure. So more of the same, people, more of the same. Measure angle 1. So I'm looking at angle 1. Vertex is on the edge. So it's the same calculations. The angle is half the intercepted arc. So in your head, what's half of 210? 105. Too easy. Okay, find the measure of arc XY. Okay, so we got to be a little creative on this one. So you know this angle's 80, whose vertex is on the edge. So I can get its intercepted arc, of course. I'm going to double it by double 80. So here's where we have to use some previous knowledge, of course. How many degrees are in a full circle? And if you have 160 right now, how much is left for the red part? 200. So this is one of those problems where your previous knowledge of full circle is 360 came into play for you. So the first thing, of course, nothing new. Now we're going to get to the new stuff. Intersecting lines and circles. So there's nothing for you to fill in. Just look at these pictures for a minute. If two lines intersect a circle, there are 3 places that the lines can intersect. So you can intersect on the circle, you can intersect inside or outside. And we're going to talk about all of those 3 different possibilities, how you calculate the angles, how you calculate the arcs, all of that good stuff. So let's talk about inside the circle first. You're intersecting inside. So a few things you got to fill in on the blank. If 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum. Remember, sum means add, people. So filling these in on your blanks, on the notes. Sum of the measure of the arcs intercepted by the angle and its vertical angle. Now that is incredibly wordy, I think. So that's why I have this very lovely star down here. And I'm going to fill it in and try to make this a little easier for you, okay? So if you want to find, of course, the angles, this is what they're looking at. Like if you want angle 1, it's going to be half of its intercepted arcs. On the vertical angle, so straight across, you're going to add the blue and the red arc, whatever it is, and divide by 2. You're averaging them together. That's what I think of. So you're going to take your arcs. I'm just going to say arc 1 and arc 2, and we're going to average them. So it's half of them. And you're going to see, super easy. But what you have to remember, there's a lot to remember, because there's 3 possibilities, okay? We're doing the inside the circle. Outside's going to be different. Inside the circle, it's 1/2 the arcs, the vertical angle arcs, you add them up and divide by 2. It's half of that sum. Add them, divide by 2. This will be a different calculation, and we'll get to that in a minute. Okay, here we go. Let's do some. Flip it. Find the value of x. Okay, we got it. So inside the circle. So x's intercepted arc is this guy, the 156. Its vertical angle arc, so across from it, is 130, so I'm going to add those up. And then we average it. We do half of this, or I just think of it easier, I divide it by 2. And clearly I just typed that all in my calculator earlier. I'm just going to give you the answer. It's 143. So you average the arc of the angle and the vertical angle arc. You average the 2. You add them up and divide by 2. Okay, so I hate when they do a question mark, it just irritates me. I'm gonna call it X. I don't like the question mark, I don't know why, I just don't. Okay, so this one's a little bit different. It's the same setup, but this time they tell you the inside angle. So 77 equals. Now, its intercepted arc is 85. The vertical angle arc, so across from it, that's the question mark, what we're trying to find, but I recalled it X, so I don't like to write the question mark. And we have to average. So now I just have to go through and do some algebra and solve this. Now, always, let's clear the fraction. To get rid of divide by 2, I'm going to multiply each side by 2. So these will cancel out. So you might need your calculator for this. What's 2 times 77? 154. And then, of course, we're just going to subtract 85 off. You can do that. I have faith in you. So this one was a little different than A because they gave you the angle, but the setup's the same. The angle equals the sum of the arcs divided by 2. You average the arcs. All right, let's do a couple more of these before we do the other ones. Okay, so my angle, 115. So its intercepted arc is the 22 plus 12x. Nice algebraic expression. The vertical angle arc is 64. So we're going to add them together, divide by 2. So there's the geometry, there's the setup. Now, of course, it's a bunch of algebra work, okay? So first, like the last one, I'm going to clear the fraction. I'm going to multiply each side by 2. 2 times 115, 230. Now, to save us a little bit of writing on the right side, I got my 12x, of course. I'm going to go ahead and add the 22 and the 64 together. Let's combine those. 22 plus 64, 86. Now it's not so bad. We're going to subtract 86. We're going to divide by 12. Now we're just really all to our calculator. So 230 minus 86. What do you got for 230 minus 86? I like it. Divide by 12. X is 12. So, I mean, the math really, it's not that awful. You just have to remember the setup. I add the arcs, I divide by 2. So let's do another one. Practicing. Okay, so I always start with my angle, 39x minus 1 equals. Now I add the arcs. So its intercepted arc is the 141. The vertical angle arc is 91. And of course, we're going to divide by 2. So there's my setup for that. Now, the nice thing on this one, I'm not going to multiply each side by 2 like I did in the past, because look on your right side. You have all numbers. You can literally punch this in your calculator, and it's going to give you a number answer. 141 plus 91, punch that in first. I'm going to have you punch it in. Because I swear, every year kids set it up right, then we botch the calculator work, and I don't want that to be you. 141 plus 91 divided by 2. What do you get? What number?
116.
Perfect, Cody. Now it's easy. We solve it. We add 1, divide by 39. Divide by 39. I gotta look. I forgot what it was. 3. There we go. So, just to recap, okay? Because I'm gonna switch it up for you. Inside, we add the arcs, divide by 2. So the next thing we're gonna look at is outside. What happens if they intersect outside the circle? Let me click it ahead here. That is the next thing we're going to take a look at. A few things, of course, you got to fill in on your note sheet. If a tangent, a secant, two tangent, or two secants, whatever, intersect outside. So you have to fill in the word outside. That's your first blank. Then the measure of the angle is 1/2 the difference of the intercepted arcs. So difference, this time you are subtracting. That's really the only difference from our previous problems we did. The previous ones I added, now I subtract. So you have to keep this all straight in your mind. If they intersect outside the circle, outside the circle, outside the circle, you are subtracting them. And notice, I've got the far arc, the big one, minus the close one. So it's always the big number minus the small one. If you go the other way, you'll get a negative. You can't have a negative. So you also have to fill this in on your note sheet. So I think I have that on there for you. And the other thing too, okay, don't get caught up. This is so wordy, I know. Tangent, secant, 2 tangent, 2 secant. Don't get caught up like, oh my God, is it 2 secants? Is it a tangent? Who cares? I don't care what it is. I care that they intersect outside the circle. If it's outside the circle, I subtract. If it's inside the circle, I add. I don't care if it's secants, chords, whatever. That's what I keep straight in my head. So here we go. So outside the circle. Outside. So the angle. So the setup is similar, but of course we are subtracting. Now, a little common sense here, because sometimes it's easy to be like, oh, do I do 76 minus 178 or 178 minus 76? Well, we can't have a negative answer, people, so you have to start with the bigger number. So 178 minus, this time, outside we minus our close 176, and of course we divide it by 2. I literally just typed that in the old calculator. Now look, it's 51. Nothing magical. So outside the circle, we subtract. That's the only difference. So again, I'm outside the circle. So this time they told you the angle. So my big arc is A. This time we subtract because we're outside. My baby arc, my near arc. And we divide by 2. So there's the setup, same process, we subtract. Now, I'm going to multiply each side by 2 to get rid of the fraction. I know you guys hate fractions, I don't know why. Okay, 2 times 30, nice and easy, that's 60. And then, of course, you just add the 44 over. You can just do that in your calculator, maybe in your head. 104. So outside the circle, you subtract. You're going to hear me say that a lot to help keep it all straight in our mind. Okay, we are outside the circle. Now, you know I hate the question marks. I don't know why, I just hate them. I'm going to recall this X. And you can too on your homework. Some of them have the question mark. If you relabel it X, I don't care. Okay, so my angle. I got a problem, people. I need this arc, the big arc, the far arc. They didn't give it to me. Does that mean we can't do it? I see some of you on your calculators. Full circle should add up to what? 360. So I got to use my previous knowledge and do a little, 360 minus 131. What's 360 minus 131? 229. So I did have to do that little calculation. Now I'm ready to go. The big arc minus the little baby arc divided by 2. And then I punch that all in the calculator. Bing, bing, boom. I gotta look, it's 49. So again, previous knowledge, the 360 or the 180 you can still use, of course. All right, outside the circle, so I know I'm subtracting. This time, of course, they tell you the angle, 11x minus 11. Okay, my far arc is the 33x plus 15. We got a lot of variables in x in here. This is going to be a good one. I can feel it. Minus. Now, our near arc, our smaller arc, is this guy. 16x plus 2. Now, I'm a little worried about this because I have to subtract everything I wrote in blue. So I know I'm going to subtract the 2 at some point. Just to make sure I don't miss a sign or screw something up, I'm going to put it in parentheses. And let's not forget, we're over 2. That is a beast, okay? So the geometry part, if you ask me, is pretty easy. We got a whole lot of algebra to deal with on this. Now, doesn't matter what you deal with first. The over 2, if you clean this up, doesn't matter. I know we hate fractions. Let's get rid of the 2. I'm going to sneak it in here. I'm timesing each side by 2. Okay, so I'm going to do 2 times 11. I'm going to distribute the 2 through here. 2 times 11. Now, because I don't want to mess up a sign, I'm going to go ahead and distribute this minus through. So I'm going to rewrite everything here step by step. So I have minus 16x and then minus 2. Sometimes it's easy to forget that 2 turns to a minus. A lot of like terms over there. This is like the world's worst algebra here happening, but we can handle it. Let's combine our x's. 33x minus 16x, I'm going to combine that to 17. 15 minus 2, 13. We're still going. I got to get the x's on one side, so I'm going to subtract 17. Okay, 22 minus 17, 5. Whew, my arm's starting to hurt. We're going to add 22 over 22 plus 13. And we get a nice final answer of 7. Whew. Now, are they all this bad? No, I mean, clearly the last one was super duper easy. That wasn't a big deal. But you might have a little more algebraically heavy problems on a couple of them today. That's why I wanted to make sure we did a couple with you in class. All right, let's do another one, shall we? So we are outside the circle. Outside subtract, inside add. Okay, some angle equals the far arc 230 minus that blue arc. What's the blue arc, people? They didn't give it to me. Can you figure it out? 130 for the win, because the full circle's 360. So that's how we had to find that, of course, and we're over 2. Now, the nice thing is, look at your right side. It's all numbers. You can just crank that into your calculator, and it's going to kick you out a number answer. 230 minus 130, probably do this in your head. 230 minus 130, 100. What's 100 over 2? 50. I'm going to subtract 1 off. Nice and easy, x is 7. So you still may have to find one of the arcs using the, they all total 360. Love it, hate it, love it, hate it. Well, Cody's sneezing, I don't know what that means, but we're going to go with it. So let me give you your homework, okay? Your homework